Now let us create one more file using touch p4.sh. Now the program is for p4.sh is created. Now the first statement is if check whether the file entered is type of file is of which type, and syntax for this is file space and -b. -b will check for whether the entered file is of which type, -b, and file name with extension. Suppose we will enter p1.txt and file in case -b and p1.sh. Now these both of these output in both of these cases will be the ASCII type. Why it is showing the ASCII? If as we are entering or we are basically moving for the numerical things and the text, and these are the ASCII types, and that's why it will display the output as ASCII. This is the first, that is file type. Now the second is whether the content or number of lines or number of links in the file, number of links. Okay, how can I calculate for the number of links? The number of links can be calculated with the help of ls-l. ls is a command used for displaying the list of files, and according to -l each and every line will be calculated and get displayed according to the links. And there are two types of link. One is hard link and another is soft link. In case of hard link, whenever any link will be created, then the copy of the same link will be created, and if we delete the original one, then also it will not impact on the original file. But whenever there is a soft link, then that soft link will have the impact of any kind of these things. Means if we delete the original file, it will create the huge impact on this, and if the original file will be get deleted, then impact of that is zero in case of hard link. And if it is not the original file, then the, or in case of soft file, I will repeat, in case of hard link and soft link are the two types of file. Hard link, whenever we have created one file and we are deleting the original file, then it will not have any kind of impact in case of hard link, as there is a copy, one of the copy of that link will be created, and that's why if we delete the original, then also it saves for the, or it doesn't have any kind of impact on the same. In case of soft link, it causes the huge impact. Okay, and this is the main difference between hard and soft link. The next is one is file type, next is hard and soft link or display the number of links, and third is for access time. The access time will be calculated with the help of stat command. The stat, and the syntax is stat space file name with extension. Now let us save this first and go to the terminal and execute it with the help of bash space p4.sh. Now, as you are able to look for ASCII text, that is the output of file -b, and these many links are created for the file ls-l. Now, once the file is executed or created, it is with the help of, now you are able to observe the difference p1.txt and p1.txe, as In my first case, I have created the I have taken the chmod 777 and the permission for this, and two files are get created. One is now both the files are having read and write permissions, and now observe the link. There is read, write, and execute permission. Execute permission is written with the help of X in this case, and rest files are having read and write only permission. In the other cases are for reading and writing. In the case of whenever we are executing chmod 777 and space file name with extension, then read, write, and execute permissions can be achieved. This is the ls-l will have the output of ls-l will be this, from total up to this. And now the access time, that is stat, that, and also this will be the output. Okay, and now the output in case of stat will be this: access time and the number of blocks, number of links. No, this link will be ls.-l. This will be the output in case of ls-l, and this will be access, the context, modify, birth of the file is the date 12, that is month 12, 16th 12 2014 from 10:44. This is the time, and this will be the content, and change as there are almost small content, and that's why this number will get vary, that 0500, if the content gets varied. That's all for this stat. Now we will go for the program of factorial. For this, I will create one more file named touch and f1.sh. As this is a program of factorial, we will go for f1.sh. This is my file. I will open and I will write the program of factorial. Echo enter any number. After that, as we know, echo is used for displaying the content, and whenever we are taking any kind of user input, we are using read for taking the input entered by user and storing it and using it for the future purpose. Read, and after that v1 will be the variable, suppose, or n or num will be the variable. Okay, after that, what will be the next step? F is equal to 1. Why? Because we are expected to calculate the factorial, and for doing it we are initializing f as 1. Now always remember, this is the global declaration. F is equal to 1, it is termed as global declaration. If I will write f is equal to 1 before any kind of logic, it is termed as a global declaration, and if I will write it within the logic, within any loop, then it is called, or within any kind of logic, then it is called local variable. In this case, f is equal to 1 is global variable. Global variable. Okay, after that, while, and with the help of while I will try to execute one of the things, that is user input. I am taking $num dash gt stands for greater than, and it is checking whether it is equal to 1 or not. I will write dash gt stands for greater than, and after that, as we know, the syntax of while is do, and it will close with the help of done, do, and done, and logic will be executed or enrolled in between do and done. Okay, for doing this, we are expected to calculate both the things, that is num is equal to and fact is equal to. I will write this num, and before calculating this num, I will calculate f is equal to. As we know, for doing any kind of arithmetic operation, we always use dollar, and both the parentheses are expected. dollar, and this is syntax, and we will write whenever I am calculating factorial of any number. Factorial of any number can be calculated with the help of f into num. Calculate f into num. Okay, and as we know, number will be deducted by 1 every time, and how many times that number will get deducted till 1 comes at the end. Why 1? Whenever we are multiplying anything with 0, then the output will be 0, and as we are doing the factorial program, then anything multiplied by 0 will get or will display the result 0 in that case, and that's why we will stop when the 1 comes. And after that we will try to execute the echo $f, then factorial will get displayed. Now, okay, now that factorial f can be displayed. Why? Because I have mentioned that f is equal to 1 globally, and if I'm not mentioning that f is equal to 1 globally, then in that case, if I'm writing that f instead of here, I will write that f here. That means f is equal to 1. I will write in this position, it will be the local variable. Local variable. Okay, variable. Now in our case, variable. Okay, in our case the local variable is not expected, instead global variable is expected, and hence I will erase it. Now let us try to execute the same, and I will execute it with the help of bash space. What is the name of file? f1.sh. Enter any number. I will enter 5, and factorial of 5 is 120, and the program is this. This is the last program, and we will. Okay, but before last program, we will try to execute one more program that was left, which is the program regarding fetching each, and I will clear my output first for this. Oh, that I have written it here by mistake. I will save this, and I will write it clear here. And this is the program where we are fetching all the files and directories which are saved in the system, and after fetching all the files and directories which are saved in system, we are trying to mention whether it is file or not, whether it is directory or not. This is the program where for x will store each and every value which will be determined with the help of x star. Why $x star? X star will take the all values of files and directories, and it will save it in x. Now after that, do and done, it is the syntax for for. For will starts from do and ends with done. Okay, and with a, if we are checking whether the file or directory or whether the input is file or not. For checking whether the input is file or not, dash f is used. With the help of dash f, it will display it is a file. In case it is a file, then it will go inside. In case it is not file, then it will go in the case of elif. Dash f will be used for displaying whether it is file or not, and if it is a file, in that case it will display $x is a file, and if it is a file, in that case number of lines in the file it will calculate, and for calculating the number of lines in the file, wc command is used. Wc with dash l. Wc is command used for word count, and space dash l means word count with the help of line, and $x is used for fetching entire content whether it is file or directory. Obviously, in this case, if it is file, then only it will enter, and it will display the number of lines in the file. elif, if it is not a file, then it will go for if it is a directory, and if it is not a file, it will be directory, and it will display the entire content accordingly. And if it is whether it is directory or not, it can be checked with the help of dash d. There is difference between dash d and slash d. Dash d is used for checking whether it is directory or not, and previously we used this slash d, it is for deletion. Okay, and whether it is directory or not, and obviously the if will end with file. The syntax of if then logic, and else, and then it is extra or additional part. When we are using elif, in case we want to check the multiple conditions, in this case we are checking for two conditions, whether it is file or not and whether it is directory or not. We cannot check the condition with the help of el or else, and if I want to check the condition with the help of else, then I have to write elif in this case, and condition will be tested, and accordingly the execution will get done. Now let us try to execute this. For execution, once again we know the bash space p3.sh. It will display the number of lines in the file. Okay, now let us count the number of lines in this. That is f1.sh. Number of lines in the files are 9. 1 2 3 4 5 6 7 8 9. Okay, it is in case of p3.sh, the line is here and it's displaying the content 9 with f1. We have here p3.sh. Observe the content of p3.sh. These are the 12 lines. Now let us check. 1 2 3 4 5 6 7 8 9 10 11 12. And in case of f1, let us for f1, let us look for f1. F1 was the file for checking whether it was the number factorial. In this case, line is displayed 9. The output in this case is 9. Let us check. 1 2 3 4 5 6 7 8 9. Okay, and I will repeat it. In case of f1.txt, it's showing 9. This is f1.txt. 1 2 3 4 5 6 7 8 9. That will be the thing. And in case of p3.sh, now 1 2 3 4 5 6 7 8 9 10 11 12. 12 is in the case of p3.sh. This is p3.sh. This is 12, and 1 2 3 4 5 6 7 8 9 10 11 12. And in case of f1.sh, it's 9. Let us count. Now let us count. 1 2 3 4 5 6 7 8 and 9. That's all about the factorial, and entire content of Linux is covered now.